Assalamualaikum and hi, we are from AS1204B. We would like to present our video assignment with the course code CHM256 with the topic of paper chromatography, and our title is the dimensions of separating gel pens in using paper chromatography. And our table of content is introductions of paper chromatography, applications of paper chromatography, and the conclusions. Next, I would like to introduce our group members in this video assignment. First, we have Adil Ilana binti Azri, Fatino Alisa binti Rezaki, Nur Hidayah binti Razak, Nur Ayrin Shafia, Nurul Aini Shah. And I will talk about the introductions of chromatography. Chromatography is the method of physically separating mixture in its component. It is a common laboratory technique used to identify unknown component in its mixture. A chromatography is a method of separating mixture into its individual components based on their different interaction with two pieces. First, we have stationary phase, a fixed phase that does not morph, solid or liquid. And second, we have mobile phase. Mobile phase is a phase that moves through the secondary phase, gas or liquid. As the mixture moves with the mobile phase through the secondary phase, each component interacts differently depending on its properties, leading to the separations of the component. The purpose of chromatography experiments can be included in first, identify ink components. We can determine whether the inks used in various gel pens are mixture of pure substance by observing their separations into distinct pigments. Second, calculating retention factor (RF) by measure and compare the RF value of the different components in the inks to identify their chemical properties and migration behavior. Third, we have analyzing solubility and affinity. We can understand the interactions of inks components with the stationary phase, which is papers, and the mobile phase, which is solvents, based on the difference in the solubility and polarity. And fourth, we have comparative analysis of inks. By compare inks from the different gel pens to identify similarity or differences in their pigment compositions. And lastly, we have real-world applications. We can apply these findings to the practical context, such as forensics analysis or quality control in the ink productions.
The objectives of this experiment is: the first objective is to use paper chromatography to identify whether certain colored ink are pure substances or mixtures. The second objective is to obtain a paper chromatograms of various gel inks. And the last objective is to identify components of inks by calculating the RF values. Theory of chromatography. Chromatography operates on the principle that molecules in mixtures interact differently with a stationary phase, whether solid or fluid, and a mobile phase, leading to their separations. Factors influencing this process include molecular properties such as absorptions, liquid-solid, partitioning, liquid-liquid, affinity, and variations in molecular weight. These differences cause some components to remain in the stationary phase longer and move more slowly, while other transitions quickly into the mobile phase, exiting the system faster. Theory of experiment. The experiment of separating gel pen ink using paper chromatography is a method used to separate the different colors in ink. A small amount of ink is placed on a chromatography paper and a solvent moves up the paper. As the solvent travels, it carries the ink's component at different speeds, causing them to separate into distinct colors. This helps identify what makes up the ink.
The apparatus used for these experiments included chromatography paper, a pen, gel pens, a 600 ml beaker, a ruler, plastic wrap, tape, and paper towels. The chemical used were distilled water and developing solvent. These were the materials and chemicals needed for the chromatography experiment. Now I'll be explaining how to prepare chromatography paper for the experiment. First, hands are thoroughly washed to remove any oils or residues that could interfere with the experiment. A ruler and a piece of chromatography paper are then obtained. The paper is handled only by the edges to avoid leaving fingerprints that could affect the elution process. Second step, the chromatography paper is placed on a clean surface, such as a notebook or paper towel, to prevent contamination. The paper is oriented in landscape and the name is written at the top edge in one corner. By using a pencil and ruler, a straight line is drawn about 1.5 cm from the bottom edge, marking the starting line. The second line about 10 cm above the first, is drawn as the finish line. The step, starting from the line, measurements are made about 2.5 cm from one side and a small X is likely drawn at the center of the starting line. 7 additional X are spaced 1.5 cm apart along the line. Fourth step, ink spots are placed at the center of each X in the following order: black, burgundy, red, pink, violet, turquoise, green, and blue. Fifth step, each ink spot is checked and gone over a second time to ensure there is enough ink. The last step is the chromatography paper is carefully curled into a cylinder with the ink spots on the outside. The ends are taped together, making sure that the edges don't touch each other. If the edges touch, the element may move diagonally, causing the spots to merge or not form distinct lines. At this point, the chromatography paper is prepared, resembling the setup shown in figure 3. This preparation step is essential before proceeding with the actual chromatography process.
I will now explain the process of acquiring the chromatogram. First, 25 ml of the eluting solution was poured into a 500 ml beaker and the paper cylinder was carefully inserted into the beaker, ensuring that the ink spots remain above the liquid level. The beaker was then covered with plastic wrap to prevent evaporation and the setup was left undisturbed as the eluent slowly moved up the paper. This process took approximately 45 to 90 minutes, during which the solvent front rose gradually. Once the solvent front reached the finish line, the paper was carefully removed, allowing any excess eluent to drip back into the beaker. Finally, the chromatogram was taped onto a paper towel and left to dry in the fume hood. After acquiring the chromatogram, the next step was to analyze it. First, the original ink colors were labeled under each mark on the chromatogram and their locations were circled. Using a ruler, a distance from the starting line to each ink mark was measured. This was recorded as the D value in centimeters. Next, the distance from the starting line to the solvent front was measured. This was recorded as the F value in centimeters. To determine the retention factor RF for each ink, the formula RF equals to D value over F value was used. Lastly, all the measurements and RF values were recorded in the lab report.
These are the results of paper chromatography using gel ink pen. As from the result, the solvent front reached about 10 cm from the starting line. As the solvent moved, it separated the ink into dye components based on their affinity to the solvent. As you all can see, the red, blue and turquoise did not separate, indicating that each of these contained a single dye component. However, the fourth sample, which is a multicolored ink, shows separation into a multiple component, which is red and black pigments. Furthermore, the blue color travels farthest with the mobile phase because the polarity of substance significantly influences their movement and separation during chromatography. Polar substances have a stronger attraction to polar tertiary phases and will move more slowly through the chromatography system. This is because polar substance can form dipole-dipole interaction or hydrogen bonds with the polar stationary phase, causing them to stick to it. On the other hand, non-polar substances have a stronger affinity for the non-polar mobile phase and will move more quickly through the system. They do not form stronger interaction with the polar tertiary phase and are carried along with the mobile phase. This is why blue color has higher solubility with the mobile phase and has a weaker attraction with the stationary phase. Also, it has a stronger affinity with mobile phase, allowing it to move more easily and travel greater distance following red, turquoise, and black. Next, to quantify the observation, we need to calculate the RF value for each pigment. So, RF value is the ratio of the distance traveled by the pigment divided by distance traveled by the solvent. Before that, we need to find the distance traveled by the solvent, where we need to subtract 10 cm with 1.5 cm, then we'll get the 8.5 cm. Moving on to the first color component, which is red. If the red pigment travels by 7 cm, while the solvent travels 8.5 cm, the RF value will be 0.82 cm. Following the blue color is 0.94 cm and turquoise color is 0.71 cm. And the black color is 0.59 cm. Thus, this experiment demonstrates the effectiveness of a paper chromatography and successfully separated the components of different gel in pen. In this experiment, paper chromatography was successfully employed to analyze the ink composition of a gel in pen. The separation of pigment demonstrated the presence of various dyes within the ink, as evidenced by distinct color band formed on the chromatography paper. This result highlights the effectiveness of paper chromatography in distinguishing the chemical components of gel ink, showcasing its applicability in qualitative analysis. This simple yet powerful technique can be utilized in diverse fields, including forensic science and quality control.
These are all the list of references that we use for this presentation. That's all from us. Thank you for listening.